Welcome, my friends, to a place where we share inspiration and positivity. Welcome, everyone, to our latest video where we'll be exploring SES-9. SES-9 is a geostationary communications satellite operated by SES. It was launched from Cape Canaveral SLC-40 by a Falcon 9 full-thrust launch vehicle on 4 March 2016. In the upcoming portion, we'll be dissecting satellite description to gain a comprehensive understanding of its implications. SES-9 is a large communications satellite operating in geostationary orbit at the east, providing communications services to Northeast Asia, South Asia and Indonesia, maritime communications for vessels in the Indian Ocean, and mobility beams for seamless in-flight connectivity for domestic Asian airlines of Indonesia and the Philippines. The satellite was built by Boeing, using a Model B SS satellite bus. SES-9 had a mass of at launch, the largest Falcon 9 payload yet to highly energetic geosynchronous transfer orbit (GTO). SES used the spacecraft's own propulsion capabilities to circularize the trajectory to a geostationary orbit. In the next segment, we'll be exploring market and coverage and its implications for our subject matter. SES-9 has 57 high-power Ku-band transponders, equivalent to 81 transponders of 36 ms bandwidth and co-located at I alongside SES-7. It provides additional and replacement capacity for DTH broadcasting and data in Northeast Asia, South Asia and Indonesia, and maritime communications for the Indian Ocean. Broadcasts are on 6 Ku-band coverage beam South Asia beam, centered on India with a 55 signal 40 dish and taking in Pakistan, Bangladesh, Sri Lanka, Nepal, and parts of Myanmar. Northeast Asia beam, centered on the Philippines with a 55 signal 40 dish and taking in the eastern seaboard of China and parts of Indonesia. Southeast Asia beam, centered on Indonesia with a signal 45 dish and taking in Malaysia, Singapore, and parts of Papua New Guinea. West Indian Ocean beam, centered on the Gulf of Oman with a 53 signal 50 dish and taking in the Arabian Peninsula, East Africa, and the western coast of India and Pakistan. East Indian Ocean beam, centered on the Bay of Bengal with a 54 signal 45 dish and taking in southern and eastern India, Sri Lanka, and parts of Bangladesh, Myanmar, Thailand and Malaysia. Australia beam, centered on Adelaide in Australia with a 55 signal 40 dish and taking in South Australia and parts of Western Australia, Northern Territory including Alice Springs, New South Wales and Victoria. Brace yourself for a deep dive into contract and scheduling as we explore its impact and relevance in our evolving narrative. In addition to the earlier SES-8 mission ordered in 2011 and launched in 2013, SES contracted SpaceX for 3 additional launches starting with SES-9, originally planned for 2015. The deal was announced on 12 September 2012. In early 2015, SES announced that it would be the launch customer of the next rocket evolution by SpaceX, Falcon 9 Full Thrust, also called Falcon 9, and later, just Falcon 9 Full Thrust. At the time, SES expected SES-9 to be launched by September 2015. Despite the failure of the CRS-7 mission in June 2015, SES reconfirmed in September 2015 their decision to provide the first payload for the new rocket variant. However, the launch was postponed until late 2015. Eventually, after considering all options, SpaceX announced a change on 16 October 2015. Orbcomm's 11 Orbcomm satellites would be the payload on the return-to-flight mission of the redesigned rocket instead of SES-9. The Orbcomm payload with its lower orbit would allow SpaceX to test relighting the second stage engine, a capability required to successfully put the heavier SES-9 on a geostationary orbit. The Orbcomm mission was subsequently delayed to mid-December 2015, while SES-9 was scheduled to follow within a few weeks. Finally, Falcon 9 full thrust performed its maiden launch on 22 December 2015. The final launch of the Falcon 9 variant followed in January 2016, with SES-9 moving to February 2016. Consequently, this was the second launch of the full thrust variant. Prepare yourself for an eye-opening discussion on launch attempts in the upcoming portion of this video. A successful static fire test of the rocket was completed on 22 February 2016. Thumb-Prior left Flight 22 on 24 February 2016 launch attempt, which was scrubbed prior to loading propellants. The launch was initially scheduled for 24 February 2016 at 11:46 UTC, with a backup launch window the next day at the same time. Neither day produced a launch, however, as both attempts were scrubbed on 24 February 2016 prior to propellant loading out of an abundance of caution, in order to get the rocket's liquid oxygen propellant as cold as possible, and on 25 February 2016, just 2 minutes prior to launch, citing a last-minute problem with propellant loading. Subsequently, the launch was rescheduled for the evening of 28 February 2016 at 11:47 UTC, with a fallback slot same time next day. On 28 February 2016, launch attempt was aborted less than 2 minutes before scheduled liftoff due to a tugboat entering the area of the offshore safety zone. A second attempt on 28 February 2016 was made about 35 minutes later, after the downrange zone had been cleared. However, the rocket shut down a moment after ignition due to low thrust flag from one engine. Rising oxygen temperature due to the hold for the tugboat to clear and a suspected helium bubble. The two are related. The helium bubble in the warmer LOX was affected by the earlier launch attempt, when the stage was pressurized with helium for some time, increasing the saturation of helium gas into the liquid oxygen, which could then bubble out when the turbopumps began rapidly drawing oxidizer from the tank for the launch, and lowering tank pressure in the zone around the turbopump inlet was suggested by Elon Musk as the likely reasons for the alarm being triggered. The next launch attempt on 1 March 2016 was postponed to 4 March 2016 due to high winds. Thumb-Prior Falcon 9 Flight 22 launching on 4 March 2016, carrying SES-9. The launch was finally attempted and succeeded on 4 March 2016 at UTC. Moving on to the next segment, we have orbit adjustment. The original apogee for the transfer orbit contracted by SpaceX was a subsynchronous highly elliptical orbit that SES would then circularize and raise over several months before the satellite would be ready for operational service at SES CTO. Martin Halliwell indicated in February 2016 that SpaceX had agreed to add additional energy to the spacecraft with the launch vehicle, and that a new apogee of approximately was the objective, in order to assist SES in the satellite becoming operational many weeks earlier than otherwise possible. In the upcoming section, we'll be dissecting post-mission landing test and exploring its intricate connections to our topic. Following word from SES that SpaceX had allocated some of the normal propellant reserve margins for landing to placing the SES-9 satellite in a higher and more energetic orbit than originally planned. SpaceX confirmed in February 2016 that they would still attempt a secondary goal of executing a controlled descent and vertical landing flight test of the first stage on the SpaceX East Coast autonomous spaceport drone ship floating landing platform named, of course, I Still Love You. Although SpaceX successfully recovered a first booster on land following the December launch to a less energetic orbital trajectory, they have not yet succeeded in booster recovery from any of the previous attempts to land on a floating platform. Because the SES-9 satellite was very heavy and was going to such a high orbit, SpaceX indicated prior to launch that they did not expect this landing to succeed. As expected, booster recovery failed. The spent first stage landed hard, damaging the drone ship, but the controlled descent and atmospheric ray entry, as well as navigation to a point in the Atlantic Ocean away from the launch site, was successful and returned significant test data on bringing back a high-energy Falcon 9. The controlled descent through the atmosphere and landing attempt for each booster is an arrangement that is not used on other orbital launch vehicles. SES CTO Martin Halliwell had informed SpaceX that they were willing to use the same rocket twice to power another satellite to orbit. This idea became reality in March 2017 with the SES-10 mission flying with the reused booster from SES-8. By 21 March 2016, the hole in the deck of the drone ship had been nearly repaired. Share this video with your friends and spread the knowledge.